Okay guys, so welcome to the challenge number 8 of MATLAB series. So today's challenge is quite interesting and it is one of my favorite questions. So in this challenge, we have to arrange a matrix in alphabetical order, or you can say in dictionary manner. Okay, so let me give you details. The user will give us a string vector, a vector in which strings will be present, and we have to arrange them in dictionary order. Okay, so this provide is unnecessary, so we have to arrange them in dictionary. Okay, so example, if the user says grapes, apple, guava, banana, then we have to give apple, banana, grapes, guava. So this question gets interesting when the first digit is same, then we have to check the second number. If the second is same, then you check the third number. If third is same, then we have to check the fourth number. So that's where the question gets interesting. Okay, so let's talk about solution. First of all, we will simply assign every alphabet a value, like A is equals to 1 or something like that. But it will be not be random value, it will be based on the serial number of A. Like A comes the first one, so A gets value of 1. As you can say, value equals to its serial number, and then we will assign the values to the input names based on the alphabet present in them. So like for apple, we will give it value according to the alphabet's value. For example, let's say if there is the value of A, P and L and E are given, then the value of apple would be, as you can see, A means 1 dot, P means 16, which means 16, and again P means 16, so there will be 16 also, and then L means 12, and then 5 means 05. Okay, so remember this. You can say that we are adding them by after dividing them by 100, or you can say 100 to the power I, where I starts from 0. You can say like this also. Okay, so why are we doing this? So that to give all the number a value which will be comparable, and we can sort them out on the basis of their values. If we don't put decimal, then there will be serious error in the answers. Okay, but this also becomes a limitation to the answer, because after certain time the MATLAB will stop accepting dots anymore, decimals anymore. So we can't put a too long string inside it. Okay, that's one of its limitation. Then third step is we will arrange the numbers with the lowest value appear first. Like for, let's say if there is something like triple A and there is something like double A and then B, then its value will be 1.01 or 01, while its value will be 1.0102. So this value should come first, and as we have already know that this value comes first in dictionary. Okay, so our algorithm is correct. So that's it for the explanation. Let's get to the function. Yes, also there can be multiple ways, but this one is just my favorite. There are multiple ways to solve this question, but this is my favorite way to solve this. Okay, so let's continue it. Okay, so this is the function. Okay, so let me tell you how this working. First of all, I assigned, let me do it here directly. So first of all, I made a matrix which contains all the alphabets. Then we contain a matrix of same order containing the values, or the, you can say the serial number. And then this is a matrix having all elements as zeros with the same length as A. A is our input matrix, which will which will have strings as its value. And here this function is to convert the strings to characters. So let me tell you something. Let's say if this is a string, okay, if I ask uh, something like this, then it will show a string. But if I say something this single inverted commas, then if I classify this, then it will say character. So what are the differences? Let me show you. Let's say I take A as the string sources and B as the character sources. So the difference is, if I ask that what is the length of A, then it will say 1 because it is a matrix containing one element. But if I say length of B, then it's saying 5, which means it's considering the sources as a matrix containing 5 single characters. So in this part, I converted the string array to a character array. The reason was very simple, so that I could measure the length of the string, and this will help me in finding the values. Okay, so what happens here is I could overall define 4 matrices. The B is the matrix containing alphabets, the E is matrix containing the values of the alphabets, the C is a matrix which we will use to give our final output, and D is a matrix which will be also help us in giving output. So this loop is for the number of elements in A. Like if there is a with 4 names, then this I is working for all those 4 different things. This J is working for single element, and this let me tell you this notation. This curly bracket notation is used to uh, point at some element of an cell or a struct, because now this A is no longer an array, it has converted into a struct or cell, because now it's every single element is containing another elements, as it's every single element is now a array containing characters. First of all, it was like, if I say that if A was like, so just is something like this, then this was a string array containing 2 individual elements. But if I say like convert strings to characters A, now it has become a cell array, and in cell array you can see that this is an object, and in itself it is a array. Like if I point it out something like, if I say that A1, then it will just this, but this is not a string anymore. This A1 is not a string, this is actually an array. Let me see if class function also tells us this thing. This A1 is actually not a string anymore. Like if I say if I again say like a curly bracket 1, then it is showing characters. So if I use this index, then it will show just a single string. But if I use curly brackets, then it will say a character suggest. So that's why here we want the character suggest, because we want the number of alphabets in that number. So we are using curly brackets here, and the rest is just the syntax. As you can see, I defined some variables to make it convenient for me to use, and I just basically stick to my original idea of assigning every name a value. So this K is for assigning value on the basis of every alphabet present. So here, this is where I am doing the assigning of values. So this Ci vector is actually a num vector which will contain the value of every single element or every single name of vector A in the same index as vector A. So this is happening here, as you can see, and I am doing the same thing as I told you earlier, that we are dividing it by j ki power minus 1, 10 to the power j minus 1, and then ending these functions, and then reverting back A to string. Okay, so that we could measure, so that we could easily assign the vector di to ay. So this is another loop. So as I shown you, this is part 2, whereas this is part 1. So these were the parted I have already divided into them. So I have already told you in the presentation that which two parts they were. So you can clearly see how this is happening, and at last this D matrix is now displayed. So that's how a function works. So A was the original matrix, B was the matrix of the characters, E was the matrix of the values of characters, C was the matrix containing the values of A, then D was the final matrix. So that's how a function works. I was for the A, J was for the whole word, and K was for single individual characters. Okay, let's try this out whether this works or not. Let's say I want to say like banana, guava, let's say apple, and then grapes. And if I then as you can see yourself, it's saying apple, banana, grapes, and guava. So this function works perfectly. Let's take another case. What if two elements are equal, or you can say identical? Then this will just simply show them together. There is no problem with this function. So I hope you like this. Uh, Let me give you the complete function in one go. So this is our function. This was our function. Okay, so hope you liked it, and